I call to the stage, which is actually right here, Bernd Rücker. Bernd is a software developer at heart who has been innovating process automation deployed in highly scalable and agile environments of industry leaders such as T-Mobile, Lufthansa, ING, and Atlassian. Bernd, thank you very much for being here with us. We are excited to hear what you have to say. The stage is yours.
Thank you, Ricardo. Yeah, thanks for the welcome. It's a big pity not to be on site. I really miss the venue in Budapest. I hope to be back next year. But anyway, let's do the best out of what we get. And yeah, I want to talk about communication patterns in microservice architectures. And I'm a metaphor person, so I thought what metaphor would be a good one to explain a lot of this? And food is always a good metaphor, especially after lunch. After lunch, it works better than before. So before we talk about communication in distributed systems, I wanted to talk about pizza and especially about pizza ordering. And if you want to order a pizza, then you have multiple options how to do that. If you live in a rather small town like I do, basically the only way to order pizza is to make a phone call, to pick up your phone, call the pizza place. I want to have this pizza delivered to my place. They basically take the order and yeah, normally tell me like, hey, okay, got it. We will deliver that within 30 minutes. This is synchronous blocking communication. So I pick up the phone, I cannot do anything else. I'm talking to them, I'm waiting for them to respond. I have a direct feedback loop. That's one of the advantages here, because they immediately tell me if they want to do the pizza or not, right? That gives me a good feeling in a way. Yeah, but I'm temporarily coupled now to the availability of the pizza place. So if they are currently taking another order on another with their phone, I might not get through. If they're currently, making a break, I can't reach them. I have to retry myself. So all of these kind of problems that arise from synchronous blocking communication I'm temporarily coupled, right? And that's basically my problem, not their problem. It's my problem. If I'm hungry, if I want to have pizza, I have to retry. Right. What else could you probably do? You could probably send your pizza place an email saying like, okay, hey, I want to have this pizza. Can you send that over to me? An email puts a queue in front of the communication and makes it asynchronous. And that means it's asynchronous non-blocking communication. I can write the email, I send it over. The moment I push send, it's done for me. I'm not blocked by anything anymore. There's no temporal coupling. But at the same time, there's no feedback loop. And you can think about ordering pizza via email feels weird, right? It feels like, oh, did they get the email? So if there's no pizza arriving, I might not even sure if the email has a problem, if the pizza place has a problem. So it doesn't make me feel good. I'm missing the feedback loop. You could add a feedback loop, which basically means they're sending me back an email saying we got your order and we will deliver on that. That would be a good idea in this case. Then this would also be asynchronous. Right, okay. So I'm getting back to that, why this is important to me, but there's synchronous blocking communication with a feedback loop built in. There's asynchronous non-blocking communication, which removes temporal coupling. Pretty obvious, but also important to sort it out. You will see that in a minute. One important observation here you can make is that the feedback loop is not the result. So if the pizza place tells me like, okay, we will make your pizza, it's not what I want to have. What I want to have is a pizza. And that's the result. And this will be delivered later, right? So the feedback loop is not the result. What you can see in a lot of scenarios, and taking this example from this is a local bakery in Germany, like a small one somewhere, which could be around the corner here. Actually, it's not, but it's kind of could be. And if you go in there, and if you order, for example, a coffee, then they have a coffee machine normally somewhere there, which looks sometimes a bit better than this one, but sometimes like that. And then when you order coffee, this is synchronous blocking communication with a person behind the counter, because it basically means I order the coffee, I pay for it, the person turns around, go to the coffee machine. I'm blocked by that. I watch how they basically go to the coffee machine, do whatever they need to do until at some point in time, the coffee is ready. They come back, give me the coffee, and we're done. Okay, this is how actually a lot of bakeries here work, and this is synchronous blocking behavior. Right. And one thing you can easily see with that example, it doesn't scale very well. So for basically two reasons, two use cases. The one is, if I order like 10 coffees, you will see that I'm blocking the whole bakery for a long time, right? No other customers can be served at that time because small bakeries have one person behind the counter. Second thing is, like, if I have a lot of people entering the bakery, it also doesn't scale because we have that one person and we have to serve everything one after each other. This seems to be pretty obvious, right? But translate that to distributed systems, and very often it's not. A good example, a good metaphor for a more scalable way of doing things is Starbucks, or at least I love the article Gregor Hoppe once wrote about that quite a while back already, actually. And he wrote about how Starbucks does that in a more scalable way. And it's basically they only do the first ordering synchronously. So till the feedback loop, I'm basically ordering, I'm paying, and then I'm done. That's all they do synchronously blocking. And they even nowadays replace that with an app. But even if they do it at like on-site in person, this is the part that's synchronously blocking. And then the order is put into the queue for the baristas. The baristas are scaled independently from the people behind the counter, right? Because it also takes longer. It's a more, it takes longer to make good coffee. And then when the coffee is ready, it's put into another queue where I'm basically waiting to get my coffee. And they have kind of a correlation identifier to find the right person to deliver the coffee to, which in case of Starbucks, is the name. Or in my case, it's something which is close to my name normally. If I'm not in Germany, nobody gets my name right. But anyway, okay, this is much more scalable. And again, only the first step is synchronous blocking, and then till the feedback loop, and then we're done. And this is actually a very, very common pattern, because if you look at the pizza making is something like I call long running. It takes time. And the same for the coffee making, it takes time. And the most things we do take at least a little bit of time. And long running can start with probably a couple of seconds, until here pizza making is probably whatever, 10 minutes, 15 minutes, but it could also extend to weeks or probably longer. Okay. For me, that's kind of the basic vocabulary we're using now. So that's kind of important. Now let's go back a little bit to computer science, not leaving the pizza completely, but assume you're building a pizza ordering app. Not sure if that's a good business model in 2022, but just assume that, right? So some people are ordering something, then you get, let's say, an HTTP request, an order. You want to have a synchronous feedback like, hey, we got your order. And the normal thing that should happen is that you probably also estimate like when will be a good delivery time. That's what most of the systems do. Okay, so let's assume you want to build that. With that in mind, we can look into a second, let's say, basic pattern that is interesting here at play. So you could implement that using events. So if you're looking at microservices, if you're looking around the conferences, you will find a lot of event-driven things, a lot of talks around event-driven. In an event-driven system, you would probably implement it a little bit like this. If somebody ordered, that's an event, right? Something happened. Hey, somebody ordered. And you could imagine that, because again, I'm a metaphor person. So you could imagine that like I'm pinning the order onto that kind of, order wall where all the orders are pinned to. And a lot of restaurants, a lot of bars actually have this kind of systems where they just put that small little paper, that bong, somewhere on the wall, and then the person in the kitchen takes the next one. That's kind of an event-driven system, because then this means the pizza delivery system is just responsible for putting the order there. And then let's say the cook is responsible for picking the right orders, like baking the pizza. And then probably you could see like, okay, there's a pizza ready. It could be like the pizza standing there is kind of an event because it's obviously ready. Maybe they add the original order because it needs to be correlated to the right person. Right? And that could be the trigger for the delivery person to drive it out. Right? Probably they have a couple of people waiting there in the pizza ready area saying, oh, there's a new pile of pizzas. This is the order. Okay, I take it and drive it out. This is kind of how this works in an event-driven way. The interesting part is that if you build it like that, and I'm exaggerating probably a little bit, but if you build it like that, how can you make sure that a pizza is not forgotten? Like whatever, the paper drops from the wall for whatever reason, there's a bit of wind. What happens? Does anybody recognize that? Most probably not, actually. So in this scenario, either the customer recognizes that, that would be probably the typical thing here. You call the pizza place, where's my pizza? Ooh, something didn't work well. So we hurry up now. So it's not that easy. Or you have some kind of way where the pizza delivery system is consuming all of those events and probably add at least some transparency, some visibility on top of that. And that's actually a big challenge to all the event-driven systems out there. How do you understand what's currently going on, and how can you make sure to escalate if something is not happening? How can you make sure that SLAs are met, for example, like deadlines and so on and so forth? I was talking about event-based or event-driven system. And there's one important thing to understand here. Again, it's kind of a basic terminology, but I see a lot of confusion around that. So if I call the pizza place and basically saying, okay, I want to have exactly this pizza, this is what I call a command, right? I have an intent. I want to order that pizza. That's a clear command towards the pizza place. And part of the nature of commands is they cannot be ignored. If the pizza place wants to stay in business, they cannot ignore my order. They cannot, they cannot ignore it, because otherwise customers will definitely hate them and not work together with them. Ignoring is different to rejecting. What they could do is they pick up the phone. Oh, you want to order pizza? We're super sorry. It's so busy today. We cannot deliver anymore. We're sorry, right? So they are rejecting the command. That's okay. They can do that. That's fair. But they cannot ignore it. They cannot just like throw away the phone and don't answer, right? That's just nothing they can do with the command. It's very different if you pick up your phone, you open Twitter, and you tweet, hey, I'm hungry. That's an event. It's a fact. It's clearly happening. That means you don't have a clear intent, and normally you're not controlling what's happening. It might be, right, that the pizza place knows you well enough that they kind of have the instruction, hey, if Bernd tweets that he's hungry, bake him a pizza, right? We can make a good business with that. Possibly, very unlikely, honestly, in this example. But that's the difference between a command and event. So I'm coming back to that, right? So I want to have a pizza as a command. Please send me a pizza, versus I'm hungry. It's a fact. Right. And I'm emphasizing on a lot of things here. I know, and I hope you don't find that annoying, but I find it important to sort out a couple of things, because if you think of the pizza place, and we're talking about commands and orchestration in a second, and very often this is tied to a perception where people think, okay, but I built an event-driven system because I don't want to have anything central that controls everything, and we want to have a decoupled system. I'm coming back to that as well. And the notion of commands and events is totally independent of those thoughts, because the difference is really, and you can look at that even at the individual level. Let's say the baker here bakes this pizza, it's ready. Now there are basically two options. He could say, hey, pizza salmon is ready, or order 1, 2, 3 is ready. That's an event, because he has no idea what should happen with that. It's not his responsibility. That's also an important thought. It's not his responsibility. Somebody else has to take care. He basically just tells the world the pizza is ready. He could also say something like, hey, I baked this pizza for Andrea. This is my best pizza of the day. This is a good friend. Now package it, deliver it. That's a clear command, right? It's a clear intent he has. And neither is right or wrong. It's just a different approach. In this case, the baker here, he is responsible for the pizza to be delivered correctly, right? Versus in that case, he is responsible for baking it and for nothing else. It's a different boundaries of responsibility of that. I'm stretching that of that microservice of the pizza baker. Okay. Okay, I'm coming back to why this is important. If we're talking about commands, the typical, the typical perception is, no, let's do it the other way around. If you look at restaurants, for example, especially sometimes bigger ones, what they don't have is this event-driven model anymore with the paper like running around. They very often have orchestrating capabilities, like this monitor here, which basically tells the cook exactly what he or she should do next, right? And this is orchestration. This is an orchestrator. The orchestrator knows why we want to do that food exactly now, and the orchestrator also knows what probably happens next. And what it basically displays to the person is a command, hey, please make this food, exactly this food. Okay, good. We could build a pizza delivery system with a more orchestration idea. So you could do something like, okay, the pizza delivery system now is responsible not only for pushing the right event and then don't care, but the pizza delivery system is responsible for orchestrating the chef to cook the pizza, probably observing the time that we get the pizza on time, that we're not delaying any order, and then also planning for the delivery and probably also instructing the right delivery person to bring the right pizza. Okay. This is very obvious because then you have also that point where you can understand what's happening there. Yeah, where you can control these SLAs and so on and so forth. The one thing that normally makes a bit of problem here is that we are dealing with long-running things, like making the pizza can take at least 10, 15 minutes. So we need some kind of persistent state. We need some kind of SLA tracking, so some kind of timer that gets active if it takes too long and so on and so forth. This is why I'm looking into so many of those things. So that's my, what's the English term? That's not the term I'm searching for, but let's use the term hobby. That's what my interest in, like long running things. And I'm personally around a lot with workflow engines, orchestration engines, state machines, and these kind of things. Okay. The most important thing about that slide, if you have any questions later on, if you want to discuss anything, there's my email address, there's my Twitter handle. Always happy if you reach out, always happy to discuss things. Okay. Cool. Right, and I co-founded a company. We're doing open source process automation tooling, so I'm obviously also biased in some ways. Okay, always good to know. Everybody is opinionated, but at least you know my background. And if you look at something like an orchestration engine or workflow engine, the wording might differ, but it's normally all the same. It has two core features, which is really state handling and scheduling. So you can build these basically long-running processes where it can react to certain things easy. So for example, and I'm totally making this up, I'm not sure if ever somebody did a pizza delivery app like this, but you could define a process, and this is, by the way, BPMN, it's an ISO standard for defining these things, where you could say something like, okay, if somebody ordered a pizza, that might be an event. So I'm talking about events versus commands in a second. That might be an event. Then you do a couple of steps, for example, then you trigger the pizza making. That could be the monitor in the kitchen where it basically tells you what to do next. But then you can again wait for things to happen, like, for example, the pizza to be picked up, the pizza to be delivered and whatever. And these messages here mean the process basically just waits for something to happen, for some event. Technically, that can be basically anything. And then you have options like looking at, if that takes too long, I want to do something about that. I want to escalate. I want to proactively look into that. Cool. Yeah, you can still use events. And the basic advantages you get out of that is, first of all, you have that visibility, that transparency of what's happened, right? And that's on multiple levels. First of all, like the overall process, how this is working, what's the current state, where we are currently waiting. That's more like customer calls in, where's my pizza? I can look into that saying, okay, it's in baking state. Okay, I have to click on here, which doesn't work on the slide. Then I would see exactly for how long, for example. That's the one thing. I can see when it entered the system, how long it did take here and there. I can make a lot of like reporting on that and so on and so forth. I can also see what's happening next. That's a big issue in event-driven system very often, or even in messaging systems, that you're always looking at, okay, I have a problem here, but what does this block? What would happen next, and so on and so forth. And you can do timeout handling. Yeah, I don't want to focus on that too much. The one thing I want to say is that very often when I show this, people have pictures in their head of some kind of low-code tools. They're pretty hype at the moment. And this doesn't have to be that way. So for us, for example, it means that we're what I call developer friendly. So basically you can do everything in code. If you want to look at, hey, where do I get that event from? You could write a piece of code looking at Kafka, looking at whatever MQP like RabbitMQ or whatever it is, right? Using whatever you want. In this case, it's Java and Spring, for example, but it could be basically any language. Right, and just connect everything around that. So it's not low code, it's not unhandy, it's actually super cool. Anyhow, but that brings me to what I want to talk about in more depth here a little bit. And by the way, I'm coming back to loosely and lousily coupled at the very end. So all the ends I'm collecting here should make sense in the very end, I hope. Orchestration versus choreography. There are big discussions going on at the moment around, hey, should I use orchestration, these kind of like, for example, workflow engines, or should I build a Kafka event-driven system? This is normally how the discussion goes. I try to explain why doing the discussion this way doesn't make sense here. So let's do that step by step. First of all, that's a big problem. There is no clear definition of orchestration or choreography available in the internet. So there's not a one agreed on term. That means if you Google for orchestration or choreography or orchestration versus choreography, you find weird answers. Stack Overflow has a couple of contradicting posts actually, which might not be surprising, but it shows that it's not this is orchestration, this is choreography. For the book, when I wrote the book with O'Reilly, I defined this for me and for the book. So whenever I have command-driven communication, I call it orchestration. So even that, if only the chef sends a command to the delivery person, send that pizza, that's orchestration, because the chef orchestrates the other person. Okay. Choreography for me is event-driven communication. Whenever I react to something that's happening, that's for me choreography. You could challenge that definition, but I find it at least simple enough to be understandable, and it works pretty well. So, but that's the one I'm using. And let's quickly switch examples. Not talking about pizza all the time. So the quite a while back when I discussed that super regularly, I built a system and a couple of slides around order fulfillment. So the typical I have in web shop, I want to order something there. And if you do that with microservices or with whatever, let's say DDD-based thing, you might end up with different services, different components like checkout, for example, payments, inventory, shipment. And then it can work event-driven, right? So checkout could say, hey, somebody ordered. So payment could say, oh, if somebody ordered, that's interesting. I collect payment until I can also emit an event. Hey, payment received. So inventory could subscribe to that, listen to that, and so on and so forth, right? So this is definitely a way to implement the overall, let's say, business process of order fulfillment. But again, like with the pizza, it's pretty hard actually to still see what's happening. There's not a single place where you can look at how this business process is implemented at all. Even during runtime, most of the systems make it hard to understand what's really happening. And this is a huge problem, at least to in my opinion, around these event-driven systems. And I'm not alone. So nowadays you find a lot of blog posts and stories around problems with these event-driven systems. My favorite slide is still this one from Phil Calzado. I think he talked at Graft sometime in the past as well. Anyhow, in 2019, he talked at QCon New York. And he worked at Meetup at that time. And he said, okay, we're doing this event-driven things and we were suffering from pinball machine architecture. And I, as a metaphor person, I like this name very much because it's really, it shows exactly what's happening here. You throw in an event and it bounces through the system. And I like to watch this. Yeah, took me a while to make that slide. So that's the pinball machine architecture. And this happens because you're doing too much event-driven. Now, let's contrast that with orchestration. And yeah, there are lots of thought about that. But if you think of it and think of companies like whatever, Amazon or Zalando as a Camunda customer, or whatever the big retail or webshop company is in your country, it's pretty naive to think that they let their core business process of order fulfillment emerge out of this ping pong. So what they will probably have is their own microservice implementing that capability and responsibility of order fulfillment. Or if you want to say it differently, who does the CEO blame if orders are not delivered within time, if people are complaining about orders being delayed? There need to be somebody responsible for that. And that would make sense then to also have like a microservice order fulfillment. And this might still react to events. So there is choreography at play maybe. But then if they're responsible for delivering on time, they also need to control certain things. Very often that comes hand in hand. If you're responsible for something, you want to have some level of control. And that means for like retrieving the payment, I would implement a command here. Hey, payment, now I need you to take some money, right? Because then you can also control certain things like the sequence of things. For example, you have that one place where you can look at how this is implemented and so on and so forth. There are actually a couple of good advantages about that. Sorry. Right. And for me, this is now a mixture of choreography and orchestration. And this is very often not part of the discussion. Very often it makes the impression of you either build a choreographed system or an orchestrated system. But I think you have to build a mixture. You have to understand what it means and you have to mix and match. So some communication between two components might be better off with choreography. Some might be better off with orchestration. And I'm trying to go a little bit deeper in a second. And then you could implement that orchestration, and that's another important thought, locally within that microservice. So that microservice, for example, might control the sequence of steps. Like, hey, first of all, payment, then fetching goods, then shipping goods. How payment is implemented, I have no idea. I just wait for the payment to be received. That might be an event, by the way, might be a response. Right. And now one really important thought, and it's surprising, but that's I think one of the biggest confusion that I see out in the project is that the collaboration style means choreography or orchestration, is 100% independent of the communication style. The communication style is what we talked about in the beginning, synchronous blocking or asynchronous non-blocking communication. So what that means is I can send an event on Kafka or on RabbitMQ topic. Fine, right? I can send a command on a RabbitMQ queue as RabbitMQ queue as well. You could send events via REST feeds. Nobody's doing that, but technically you could, right? So it's not at all intervened. It's totally independent, right? And this is important to understand because very often this is mixed in most of the discussions. It's going like, hey, you should send a command there. No, I don't want to have REST. REST is temporal coupling. REST is evil. No, I'm not talking about REST. You should use a command. You should basically make the order fulfillment service responsible for deciding when to retrieve payment. But you can send a message. You can put it on Kafka. I don't care. That's a different discussion. And it's important to understand that. If we're talking about orchestration and choreography, what we're really deciding on is the direction of the dependency. So if we use events choreography, it basically means the sender of the event doesn't know what's happening with the event. It just sends the event. But the recipient, basically, this service, the order fulfillment service, decides to couple to that event. So the coupling is kind of on the receiving side. With the command, it's the other way around. The payment service has no idea who sends that command. It basically offers an API and that's it. But the order service decides to couple to payment because it wants to use the service, the capability. So it uses the API, right? So the coupling decision is on the sending side. And this is the decision you can do by deciding for events or commands. And it has nothing to do with synchronous blocking or asynchronous non-block. It doesn't even have to do something with workflow engines, what I talked before. For me, that's a decision you just have to do when two components interact. Okay. And then with the idea of orchestration, for example, in order fulfillment, it gets easy to have that place where you can, for example, change the logic. Hey, we want to retrieve payment and fetch the goods in parallel to speed up things. Yeah, here you can do that. And yeah, a lot of things I could talk about that, but don't have the time. There are a couple of talks out there where I go more in depth into that. Right. And then stressing that one more time, only last time, this logic around the this process model, what's happening here, it's local within the microservice. So payment could have its own process, for example, because payment is very often also long running. So basically this, again, it's two different decisions. The one is like, hey, I want to use an orchestration engine because I have long running things where the orchestration engine can help me with implementing that easier. And the other decision is I want to use orchestration because I don't want payment to be coupled to some whatever order events, right? I want to do it the other way around. So these are different decisions you have to make. And I find this important to understand. It's very often mixed up. Yeah, and just to visualize that, because what that means is that if you do a lot of microservices, you will end up having a lot of different orchestration or workflow engines if you need that. Hopefully Camunda, but probably any other as well, right? So there are other products out there as well. Right, so it's not centralized. That's what I'm trying to get at. That's another myth people think of when I say orchestration. Oh, that centralized, whatever BPM suite, like from 15 years ago. No, right? It's totally decentralized. And there are a lot of options how we can operate it decentralized, like with SaaS and cloud, company internal SaaS and whatever. Okay, but that's not the topic for today. If you want to see some code, if you're like me, you probably slides are nice, but I want to see code. I have it on GitHub. The whole example running in this case with Java, Spring Boot, and Camunda by coincidence. Yeah, there you can play around with the thing if you like. Now coming back to events versus commands. And I like this. So I regularly discuss with Sam Newman. He wrote a couple of books about microservices, for example, this one, Building Microservices. And he has that one example in the book, making a case for events, making a case for, hey, the customer service should not be responsible for creating the customer in the loyalty points bank, for example. It's not its responsibility. It's much better if it just emits an event, hey, the customer got created, and let the loyalty points bank be responsible for subscribing to that. And I agree. That's a good design. The interesting part is, if you look at the whole onboarding experience, and we were doing a lot of onboardings with a lot of different customers, onboarding has a first phase typically where you do certain checks, and that's pretty typical, like address check or credit check or even some kind of legal checks or whatever. So you have to do a lot of clearance in the beginning before you really decide to onboard the customer and create it in some whatever system. And only then the customer is added to the loyalty points bank. And the difference now between the loyalty points bank and the checks is the customer onboarding team is responsible for the checks being made. So if you onboard customers that later on don't pay the invoices and never get a green light on the credit check, they will get a problem in onboarding. Hey, why did you onboard these customers? It's clearly not that we want to have those. So they're responsible, and that means for me, you use orchestration here because you need to control that. You need to make sure the result is used, and you need to make sure that this leads to some kind of different path, for example, through the onboarding process. Versus the customer is created, this is where the responsibility ends. Onboarding is not responsible for loyalty points bank, and nobody can go to them and say, hey, why is this customer, why did it not end up in the loyalty points bank service? They will say, we published the event, look here at that timestamp. The rest is not our problem. It's the loyalty points bank team's problem. There might be edge cases. I don't want to go into very much depth here. I did it for the book, but there are some cases, like in insurances or banks, at least in Germany, they have legal obligations to send certain letters, and they need to document that. In this case, I would also use orchestration, because then I have it documented, versus maybe the notification that you're now on board as a customer is also a letter, but not the responsibility here. Then it might be correct. I hope you get the idea. We don't have much time for that here now. So if you want to learn more, there is a lot of things in the book, and there are other talks. You will have the slides and the links later on anyway. So as a quick summary to that, so we have different communication styles, synchronous blocking, asynchronous non-blocking, and different collaboration styles, commands and events. And this is not the same, right? And you will find a couple of these examples I used here on this slide. Very important. What does that have to do with coupling? And this is what gave the talk the name, so we should definitely talk about that. If we talk about coupling, we have to talk about different types of coupling. There's a coupled system or decoupled system. There are different types of coupling. Again, there's not the world agreed on this types of coupling list. I'm using one which I think is pretty close to Sam Newman, and not that surprising, but this works for me very good. We have implementation coupling, where you know in terms of other services, like the typical joint database, different components look in the same database, which you should avoid. I'm not talking about that at all today. That's what all the microservices talks are doing anyway. Then there is temporal coupling. We touched on that very briefly. So I'm dependent on the availability of the other service, synchronous blocking communication. This is what you actually try to reduce nowadays with, for example, asynchronous non-blocking communication, classic. Deployment coupling means that you put different components together in one deployment. It can only deploy together, the typical release train thing. That's typically try to avoid it. I know a couple of customers where this works relatively well because it's fully automated. So I'm not 100% clear here, but it's also not my topic for today. So we just leave that aside. But, and this is the most important part actually. And then there is something called domain coupling. And domain coupling means there is some kind of, mixture in the business logic because you want to have that. It's a business requirement. You only want to ship orders that are paid. You only want customers to be onboarded that are cleared, that are checked. This is a clear business requirement. And the important thing here to understand, and it's pretty clear, pretty obvious actually, but it's still important to remind yourself that this is not, you cannot get rid of that by technical means. It's a business requirement, so it will stay there. It's unavoidable. And again, a lot of the discussion now mixes up different things. So in a second, give me one more slide. So domain coupling, that's what a lot of people refer to reduce by doing event-driven, which is nonsense. The collaboration style cannot decouple. You can only decouple by changing business requirements. And the communication style can reduce temporal coupling, but it's a completely different beast. Okay. Good. If you want to learn, summary, know the communication style, the collaboration style, the difference between them. You can get rid of your temporal coupling, right? Domain coupling does not go away. If you want to learn more, there's a bit in the book. Thank you very much.
Thank you very much, Bernd. We are exactly in time, so thank you very much for wrapping up very quickly in the end. I don't see any questions. I think this topic is quite niche. I don't see any questions on our Slido, but I urge the viewers, please contact with him, check the slides after, and interact, because this is the time, the place where you can actually, talk to the specialists. So don't miss that opportunity out. And with that, I will thank you very much